All right, in this one, we've got this little car and it's going up and over a hill. Okay, and it says we don't want it to lose contact with the road. Okay, so let's break it down just a little bit here. So we're supposed to find a maximum speed. All right, so I need my highlighter a bit. Okay, we're looking for a maximum speed. And so that means we're, in terms of Newton's law as a bridge, we're going to look at the forces to get to an acceleration, to get to a speed. Okay, one of those situations there. All right. Now, we don't want to lose contact with the road. Okay, so whenever you see something like that, the way that you need to interpret that is that we're really going to be looking kind of at a limit case where n is basically going to 0. Okay, so order of epsilon or something like that. Okay, so n's getting very tiny, basically going to 0. All right, and at that point there's no contact with the road anymore. Okay, so we want to be just underneath that. Okay, so for our purposes we're just going to let that be 0. Okay, but let's go ahead and set it up proper. Okay, and so if we look at our forces, because that's where we need to start, obviously we have our weight, and then we have our normal force here. Okay, and that's all that's going on in this one is a normal force and the weight. Okay, so if we jump to Newton's laws, okay, and we're in the y direction, which happens also, let's be a little bit more careful here, to be in the radial direction. Okay, now your book uses normal. Okay, so we could do this as some of the normal forces. Okay, and they've been doing it like this. Okay, now I'm just used to doing it a little bit different. Okay, but however you want to notate it is fine. Okay, that doesn't matter to me. All right, but let's see what we have going on here then. So we've got the normal force minus mg. That's MAC. Okay. Now, it's a centripetal acceleration, so we need our v squared over rho term. However, check this out. What is the direction of the centripetal acceleration? It's this way. Okay, it's in the same direction as the weight. So that means when we set it up in our equation algebraically, we need to make sure that those are compatible. Okay, and so what we're going to do then, we've got a negative mg here. This needs to be a negative term. So we're going to go negative. Let's do a little better with my parentheses. Like this. So AC is negative v squared over rho. Okay, that way everything aligns properly. Okay. All right, now, like what we talked about above, we're going to let n go to 0. So we're looking at a limiting case. If we were going to be real formal about this, we might say we need to look at the limit as n goes to epsilon, that kind of thing. But we're going to get to the same place no matter what. Okay, so check it out. My masses are going to cancel here and here. Okay, my negative signs are going to cancel there and there. Okay, so I'm left with the relationship that G is v squared over rho. Okay, we're looking for V. So V is going to be the square root. Well, having trouble with my handwriting here. Square root of rho times G. Plug in some numbers here. 250 feet is our radius of curvature. G is 32.2 feet per second squared. Boom. Okay. And quick look at our units. You can see we're going to have feet squared over seconds squared. But we're taking the square root of that, so it all comes out in the wash. And we end up with 89.7 feet per second. Okay. Just like so. Okay. Anyway, there we go. Now you have felt this driving around on the country roads. Okay, you go over a little, some kind of a ridge. Okay, and you get that kind of woo feeling. All right, so that happens as your innards inside you kind of shift positions and respond to the changing normal force. Okay, so whatever the normal force acting on your body is, then all your internal organs are hanging off of your bones inside of you. But as you have this acceleration, the normal force goes to zero, everything shifts position just a little bit. And you feel that, whoa, okay. So you literally feel your liver and your spleen and your stomach and your guts all are coming up just slightly as you go over this curve. Because they're attached by little springy little tendons and that sort of thing. Maybe ligaments is there, I don't know. Springy little connective tissue, and so they move. All right. Anyway, there you go. Pretty easy.